wanted to do some more of the limit problems. And since the limit as x approaches, and these would be from section 6.1 and 6.2 on MyMathLab. X approaches 3. When we look at the problem, first thing you want to do is plug your value in and see if you get an answer. So if we plug in 3, we get 3 squared minus 9 and 3 minus 3. 3 squared is 9, minus 9 is 0, 3 minus 3 is 0. When you have 0 over 0, there's a common factor. You need to go back and try reducing it. Notice the top can factor. So we could take the limit as x approaches 3. These are perfect squares, so it's x minus 3 and x plus 3 all over x minus 3. And notice they have a common factor. If we drop that factor out, we have the limit as x approaches 3 of x plus 3. Once we drop the factor from the bottom, plug the number in again. 3 plus 3 is 6. Oops. Let's do another one. There's one on the test where you need to find where it's discontinuous. So if we look at x squared this. Okay. If we look at this and we want to find out where is it discontinuous at. Well, it's discontinuous at any values that are omitted in the domain. So the first thing you want to do is find what you need to omit from the domain. Well, when you have a fraction, anything that gives you 0 in the denominator needs to be omitted, which means x plus 1 equal to 0. If we solve this, whatever values we get, we have to omit from the domain, because that would give us 0. So if we subtract the 1, we get x equal to a negative 1. So our domain is any values where x equals negative 1, it would be omitted. And that means that's where it's discontinuous. So wherever it's discontinuous, let's find the limit as x approaches that value and see if it exists. Well, the first thing you want to do, plug it in and see what you get. So if we plug in negative 1 squared plus 3 times negative 1 plus 2 over negative 1 plus 1. 1 squared is 1 minus 3 plus 2 is 0. Negative 1 plus 1 is 0. 0 over 0 means there's a common factor. Go back and reduce. So if we factor the top, now if you're having a little trouble getting the top factored, because we got 0 over 0, this factor is going to be up there, because that is what caused the 0. So we know we need x plus 1. x times x will get us x squared, and 1 times 2 will get us a 2. When we add these together, we get the 3. The x plus 1's cancel. So we're left with x plus 2. Now we plug in our number again. We get 1. Any questions? I guess not. Okay, let's try the limit as h approaches 0, 4 over x plus h minus 4 over 3. Oh, it was 3 plus h, not x. All over h. If you plug in 0, we'll have 4/3 minus 4/3, which is 0. Plugging in 0 on the bottom, 0. So we have to reduce this. When you have a complex fraction, if you multiply by these small denominators, it will get rid of all the fractions. So we want to multiply by 3 times 3 plus h. And you have to multiply all 3 terms by it. We're not going to multiply the bottom out, though, because we want to keep it factored so this h cancels. So looking at the first one, 3 plus h and 3 plus h cancel. So we have 4 times 3, which is 12. The next one, the 3's cancel, and we have a negative 4 times both of these. Negative 4 times 3 is a negative 12. Negative 4 times h is a negative 4h. All over h times 3 plus h. And so the 12's cancel. It leaves negative 4h over h times 3 plus h. Now the h's can cancel because there's one term on top and one on the bottom. Negative 4 over 3 times 3 plus h. Once that original h cancels, you can plug your 0 in again. Negative 4 over 3 times 3 plus 0 is a negative 4 over 3 times 3 is 9. So our answer is a negative 4/9. So look at this one here, going to infinity. We want to find the limit as x goes to infinity. So as x is getting large, y is approaching this value, which is 2 1/4. So as x is getting large, y is approaching this. Now if we look at the limit to negative infinity, as we're going this way for x, as x goes to negative infinity, so this y goes to positive infinity because it's getting large. So the limit as x approaches negative infinity would not exist because it's getting large and it's approaching positive infinity. So whenever it's getting huge, positive or negative, the limit does not exist, but then it's approaching positive or negative infinity.